Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 300, longest increasing subsequence. So given an integer array nums, return the length of the longest strictly increasing subsequence. So before getting into the problem, we want to know about what is in base subsequence, right? So if they have given array like this, okay, then I can tell you 1 comma 2 is a subsequence, 1 comma 3 is a subsequence, and 1 comma 2 comma 4 comma 5 is a subsequence, or entire array is a subsequence. Okay, meanwhile 3 comma 1 is not a subsequence, 2 comma 1 is not a subsequence, 4 comma 2 comma 5 is not a subsequence. Why it is? Because a subsequence is we want to remove some values from the array so that we will be having some other existing values in the order. That's going to be a keyword. Okay, for example, if I delete this 3 4 5, then I will be getting 1 2. If I delete 2 4 5, then I will be getting 1 3. If I delete 3 alone, then I will be getting 1 2 4 5. If I don't delete anything, I will be getting all. If I delete 2 4 5, whether I can get 1 comma 3 3 comma 1, no, I can only get 1 comma 3. Now hope you understand what is meant by subsequence. Meanwhile, increasing subsequence means the subsequence should be increasingly in an increasing order, strictly increasing order, which means its previous value should not be equal to or greater than the current value. That's going to be the that's going to be the increasing subsequence. Now what is made longest increasing subsequence? They have given an array. We want to find out the subsequence which is longest and also in an increasing order. That's what the problem statement is. Now let us get into the question. So see here, if the array is like this, then I can tell you 2 3 7 101 is going to be the longest possible increasing subsequence, right? We have other subsequence like 9 101 or 9 18 or 10 101 or 10 18, but they are not as long as this, and also they have only asked us the length of the longest subsequence, so we will be returning 4. Okay, always remember, whenever you are treating some problem, just observe what we are required to give the output. Okay, here they only want the length, not the subsequence. Okay, fine. So similarly here I will be taking 0 1 2 3. That's going to be the longest possible subsequence, increasing subsequence, right? Fine. So this is what the problem statement is. Now how we are going to treat this problem statement? Either we can use the greedy algorithm first, right? Whenever it is a longest or smallest or minimum or maximum, we are just going into a greedy algorithm, right? So how the greedy algorithm will be working here? So it is basically like I will be starting at the first. Okay, now here is 0. So whenever I am going to the next value, that next value should be greater than 0. So 1 is greater than 0. Whether 0 is greater than 0, greater than 1, no. Whether 3 is greater than 1, yes. Whether 2 is greater than 3, no. Whether 3 is greater than 3, no. So I will be having only of 3 as an output. Okay, from here I can tell you we cannot solve this question by using the greedy algorithm alone. We want to go into the all possible subsequence, all combinations. So whenever there is a combinations or subsequence or like that, the arrangements, then we want to go for a recursion. So we are having a main problem as longest increasing subsequence. We want to subdivide them and find the solution, then return back to the main problem and find the main problem solution. That's it. So this is going to be a recursion. Okay, now for designing the recursion, what and all we want? We want the function. Okay, so function, inside that function, what should I want? I should be having an index that is pointing to the current value where we are locating. Okay, and then we want the previous value. So previous value. Okay, instead of previous value, we can also take the previous index. Can you understand this? So we can either take the previous value or previous index, but it should be depending on the constraint. So see here in the constraint, they have clearly stated the num's length is up to where? Up to 1 to 2500. But num's value is from where? Minus 10 power 4 up to 10 power 4. So from this, I can clearly tell you that we want to take index, because index will be only from where? 0 to 2499. But if you take the numbers, it will be ranging from vast thing. So that's the reason why we are just going to take previous index, not previous value. Now hope you understand why I am taking the previous index as of now in this question. But in your real-time scenario, in your technical round, if they have clearly stated that in a constraint, num's length is of 1 to 2500, but nums of I is from 0 up to 100, then you want to take the value, previous value. You don't want to take the previous index. Can you understand this? Okay, fine. Now how we are just going to do this? Fine. So see here. So we have found out what is going to be the function. Now the second step is where we want to start. So I'll be starting from the 0th index. Okay. So what is going to be my previous index? So as of now, I didn't took any previous element. So I'll be having some index which is not existing, which means -1. -1 is not existing, right? So that's going to be my index. So -1 going to be my index. Okay. Let me take some other example which is shorter than this. So 0, 3, 2, 3. So this is going to be a current example. Okay. Now we are going to solve this problem to understand how the recursion works. If you don't know about the recursion tree and recursion stack, I suggest you to go and watch it first, then come back to this video. Okay, fine. I'll be giving that recursion introduction in the description. Just go and search it. Fine. So see here. First of all, we want to have how we are going to subdivide this main problem, right? We want to have an idea on how we are going to subdivide this. Okay. Now initially I am at this point. So this here is my index and previous is here. Okay. Okay. Now what are the two choices I have? I have two choices, like I can either take this 0th index element or I don't take it. As I already told you, what is my subsequence? We will be removing some value and we will be adding some value which gives a subsequence. Do the same thing here. So either you can remove it or you can take it. Okay. If we don't take, then I don't want any choice. I don't want any choice. I'll be just going to the first index and take this previous index value as itself. So previous index is lying here only, but the index is moving on to the next index value. Can you understand this? So this is the case of not take. If I take it, I want to check. What is my check? So 0th index value is greater than its previous index value. But the previous index is what? -1, which means there is no previous index. So you can absolutely take it. So take it. If I take it, it will be like 0, 1. Okay. Can you understand this? Here I have taken my index. So for my next recursion, that's going to be my previous index value. And my index will be +1. Can you understand this? So here I want to put 1 plus. Why I am putting 1 plus here? Because see here, it is a simple topic. Like if I take one element in the array, then I want to add 1 to my possible subsequence length, right? So that's the reason why I am putting 1 plus here. Meanwhile, there I didn't put anything. So for more formally, I will be putting 0 plus, but it is not needed, right? For your understanding, I am putting here alone. Okay, just understand this. Fine. Now the next thing, here also I have two steps, either not take or take. If I don't take it, don't worry, just go to the next index and keep the previous index as it is. Else if you take, you want to check whether the previous index is equal to -1. Yes, it is -1. Then take my index as index +1 and take my previous index as my index and put 1 plus. Can you understand this? Fine. Similarly here also I have two choices, not take and take. If I don't take it, don't worry, it will be off. Just like go to, sorry, here I have done a mistake. Sorry, here I done a mistake. So see here comes what? 1, 0. Okay, so here we have two recursions. One is of f of whether index +1 and if you not take, and previous will be as it is. If you take it, it will be like we want to check for a condition and put 1 plus index +1 and here comes index. Can you understand this? So this is what we have done here also. So that's the reason here we got 1, 0. Sorry, I just wrote in some mind. Okay, so see here, if I don't take it, it will be like something like I'll be going to the next index. Meanwhile, my previous remains same. Okay, if I take it, I want to check whether my 0th index value is lesser than my first index value. Okay, because the current element is first index. So whether 3 is strictly greater than 0. Yes, yes. Then what should it go? I can take it. I can take it. So if I take it, it will be like f of 2 comma 1. Okay, okay. Now again. Now here I have two choices: not take and take. Okay, if I don't take it, it will be like f of 3 comma minus 1. Don't worry. If I take it, I want to check whether my third index value is greater than the previous value, but previous value is what? Minus 1. Previous index is what? Minus 1. So I can absolutely take it. So whenever I take it, it will be like this. Yes. Similarly here also I have two choices: not take and take. If I not take, then don't worry, just go to the next index and keep the previous as it is. If I take it, I want to check for the condition whether my second index value is strictly greater than my first index value. No, 2 is not greater than 3. So here I cannot take it. So I'll be just returning 0. Because hey, you are going to the invalid path. You cannot go further beyond it. Because now you have a subsequence which is not following the strictly increasing rule. That's the reason why we have written 0 there itself. Okay. Now here 2 comma 0. So here also I have not take and take. If I not take, don't worry. Just go to the third index and keep the previous as it is. If I take, I want to check whether my second index value is strictly greater than my 0th index value. Yes. So I can take it. Whenever you are taking it, 1 plus f of 3 comma which thing you have take? Second index you have take. So that's going to be your previous. Fine. So similarly here also you have two choices: not take or take. If you not take, just to go to the next index and keep the previous as it is. If you take, you want to check whether the second index value is greater than the first index. No. At this point, what you are going to do? Just return 0. Okay. Now further. So here I have two choices: not take and take. If I not take, then it will be like f of 4 comma minus 1. If I take it, it will be 1 plus f of 4 comma 3. Why I am taking why if I take, it will be 4 comma 3? Because see here 3 is the index. So that's going to be taken, and that's going to be the previous index for the next recursion call. And similarly here also I done a mistake, right? So here instead of minus 1, I have taken it. If I taken it, it will be something like 2. Okay, I just wrote like that. Okay. Now here also I have not take and take. If I not take, it will be like f of 4 comma 2. If I take it, I want to check whether third index is greater than the second index. Third index is greater than the second index. Yes. So in this case I can take it, right? If I take it, it will be like 1 plus f of 4 comma 3. Okay. Similarly here also I have two choices: either I can not take or I can take. If I don't take it, it will be like f of 4 comma 1. If I take it, I want to check whether third index is greater than the first index. No, it is equal. So I cannot take it. So in this case I'll be just returning 0. Okay. Similarly here 3 comma 0. Here also I can take or not take, right? So if I not take it, it will be like 4 comma 0. If I take it, I want to check whether third index is greater than the 0th index. Yes. So you can take it. So 1 plus f of 4 comma 3. Can you understand this? Okay. Fine. Now come here, not take and take. If I not take, it will be 4 comma 2. If I take it, I want to check whether third index is strictly greater than second. Yes. So here comes 1 plus f of 4 comma 3. Okay. Now here not take and take. If I not take, it will be like f of 4 comma 1. If I take, I want to check for the condition. It is not a valid condition, right? So I'll be just returning 0 here. Now observe this. This is going to be main another base condition. So whenever, let me go here. Whenever I reach the index as equal to the length of the array, which means I reach the end. So you cannot go apart from that. Just return 0. Okay. Similarly here also it is what? It is 0. So 0 plus 1 is equal to 1. Just return 1. Okay. So what should I take as of here? I should be taking the longest, which means I should be taking the maximum. So whether 0 or 1 is maximum. So 1 is maximum. Take 1. Let me save this. What is the number? 300. Okay. Now next time. So this is what? This is also equal to 4, which means we want to return 0 here. Okay. Here also it is 4. So 0 plus 1 is equal to 1. So 1. Now instead of this, I want to replace as 1 because 1 is a maximum among them. So 1 plus 1 is 2. So here it is returning 2. Here it is returning 1, which is maximum. So 2 is maximum. 2 is maximum. So instead of this, I'll be replacing as 2 and 2 will be returned from here. Okay. Now come here. So here it is returning 0. Similarly here in the right side also it is returning 0. So which is maximum? 0 is maximum. So here also 0. So it is returning 0 and in my right side also it is returning 0. Okay, now 0 or 0 which is maximum. 0 is maximum. So 0 plus 1 it is equal to 1. So 1. Now 2 or 1 is maximum. 2 is maximum. So this will be replaced as 2. Now 2 is returned here. Hats off now. Okay. Now let us go to the next subtree. So here it will be returning 0. Here also it is 0 plus 1 which is equal to 1. Okay. So this will be replaced as 1. So it will be returning 1. Can you understand this? Okay. Now here it will be returning 0 and here it will be 0. So 0 plus 1 will be 1. So instead of this thing it will be 1. So 1 plus 1 will be 2. Okay. Now which is greater? So sorry, here I told like whether 0 or 1 is greater, right? So I remember like I told 0 plus 1, not it is 0 or 1 is greater. Okay. Now whether 1 or 2 is greater, 2 is greater. So here replaces 2. Return. Okay. Now go back. So here it will be returning 0 and in my right also it is returning 0. So this will be replaced as 0. So 0. So 0 0 which is maximum. 0 is maximum. So 0. Now it will be 1. So 1. Whether 2 or 1 is maximum. 2 is maximum, right? So this entire thing will be replaced as 2. Now 2 plus 1 is 3. Whether 3 or 2 is maximum. 3 is maximum. So from here it will be returning 3. So 3 is going to be my output. So if you want the longest longest increasing subsequence, then go by the path. So see here, I will be highlighting you the path. So take first take, okay, then not take, then take, then again take. So this is going to be your path. Okay, so this is your additional information. So from this I can tell you we want to take. So which means we want to take means, see here, take, not take, take and take. So what is my subsequence? It is 0, 2, 3. So this is your additional information. But in question they only want us to return the what is the longest possible increasing subsequence length. Okay, so the output will be 3. Now hope you understand the recursion, right? So again I am telling you, if you cannot understand this recursion tree, go and watch my recursion introduction video, then continue this video, because this is so much basic for our problem solving technique. Okay, fine. Now what is the time complexity? It will be over. So here we are going up to what? We are going up to n square times. For each and every recursion, I am again calling 2 recursion. So which means 2 power n square. Similarly, what is my space complexity? It is over n square because of the recursion stack. So time complexity is because, as you know, one recursion, for this one recursion I have split into 2. Again for this one recursion split into 2. Again for this split into 2, like that. So that's the reason why I got the time complexity as 2 power n square. Okay, fine. So let us get back into the coding part. So I have written the Java code. If you want the C++ or Python code, go and search in my description. Okay, fine. So see here. So here this is the main function. Here I am just returning the result of the lis helper function. Okay, here what is the varying parameter? It is index. So index is initially 0 and previous index is going to be -1. So this nums is going to be the static member, static parameter. It is not going to be changing. Okay, now index and previous index are going to be changing. Now if index reaches my nums.length, then what will I return? I will returning 0. Okay, so this is going to be your one of the base condition. Okay. Another one of the base condition can be achieved using the condition itself. Condition inside the body of the recursion. Okay, so I will be showing you that. So see here, not take is equal to, go for a recursion call where index will be +1, but the previous index will be as it is, because we didn't took it. If we take that, then only we can tell, hey, I have taken this. So in my next recursion call, keep this element as my previous value. Can you understand this? But here we didn't even took anything. So that's the reason why previous index will be remaining previous index. Okay. Meanwhile, in take, first of all, take will be 0 only. First of all, take will be 0 only. Now I want to check for the condition. If my previous index is equal to -1, which means we didn't took any values before, or else my current value is strictly greater than my previous index value, then only I want to go for a take condition. So what is the take condition? 1 plus, because I have took that particular element. So 1 plus, what is the next recursion call I want to make? So the next recursion call is go to the index plus 1 as the index. Okay, and previous index is updated as the index because index is taken as of now. In next recursion call, that's going to the previous index value. That's the reason why we have took like index plus 1 and index. Okay, now at last just return the maximum amount. That's it. Okay, if you submit this, it will not be submitted successfully because it is a huge time complexity, because it has a time complexity which is exceeding the 10 power 9, the clock time. So here we want to optimize it. So for the optimization, we are getting into the new topic called memoization. So memoization is nothing but we are just storing each and every solution of the sub problem in my memory. Whenever it is again occurring, we are just taking back from the memory instead of go and returning again from the recursion call. Okay. For this memoization, we can do this memoization in two methods. One is hash map, another one is array. So always I'll be teaching you the array method. After watching the array method, go and try this hash map method by yourself, because hash map will be so much easy and also have a disadvantage, like it will be having a time complexity slightly higher than the array, and also cannot be further optimized. Like it cannot be further optimized using the tabulation or space optimization, but array can be optimized. That's the reason why I'm taking the array for the memoization technique. Now, why we want the memoization technique? So see here, a good example is this. So it is f of 2, 1. Here also it is repeating again. Okay, as you know, we are just going down like this, then come again, go down, go up, then go down like that. Okay, so we know that recursion is a DFS. So always my recursion will be going up to the depth, then only returning back. Going up to the depth, then only returning back, which means this 2, 1, this function of 2, 1, this recursion call will be made first, and it has some solution, then only this f of 2, 1 is occurring, right? So instead of again I am going to all these recursion calls, I'll be just storing this answer in my memory, so that in future if it is occurring again, then here I'll be returning that. That's it. Can you understand this? So this is how we will be doing the memoization technique. So for this memoization technique, we want to use some set of rules. So first rule is we want to construct the array. So first, whether the array is a 1D array or 2D array or 3D array. So that for that we will be taking the varying parameters. So here the varying parameters are index. So this is the first varying parameter and previous index. So there are two varying parameters. So we want to design a 2D array. So this is the first clue. Okay. Then the next clue is we want to check what is the range of this index and the previous index. So index will be starting from 0 and it will be going up to nums.length -1. If it reaches the nums.length, then it will be returning 0. So it will be always going up to what? Nums.length -1 only. Okay. Now similarly here, this previous index will be from where? From -1 up to where? Up to, it also going up to nums.length -1. It also going up to nums.length -1. So that's going to the maximum value. Rather than that, it cannot go upward. Exactly, it will be going up to where? Up to nums.length -2. Will be going up to nums.length -2. But we want also the -1 value, right? So see here, how I am going to construct the array is, for example, the input size. The input is 0, 3, 2, 3. So there are how many elements? 4 elements. So my matrix size is going to be 4 rows at first. Okay. See here, this here row denotes what? Index, and column denotes what? previous index. Okay, just note this. Okay, so 0, 1, 2 and 3. Okay, now how many columns I want? Okay, so previous index will be always lesser than the index, right? So index will be reaching up to where? Up to nums dot length minus 1. Then my previous index will be reaching up to what? Nums dot length minus 2. But also we have minus 1. So we have 0, 1, 2 and 3. Okay, like see here, I will be telling you. So see here, 0, 1, 2, 3, right? Now for my previous value for this array will be from where to where? From minus 1, 0, 1, 2 only. This last index will be not under my previous index control, right? Because my previous index will be always strictly lesser than my current index value, right? So my previous index will be ranges from minus 1, 0, 1, 2. Since our array don't have an index like minus 1, that's the reason why instead of minus 1 I'll be taking 0, instead of 1 I'll be taking 2, instead of 0 I'll be taking 1, like that. Now hope you understand why the matrix is of n cross n matrix. Okay, fine. Now what is the next step we want to do? The next step is, see here, after this base condition I want to add another line. In front of that we want to initialize some value to this array such that value will not occur in any of the return function. So see here, in return function the returning value will be like 0, 1 or 2 or 3. So from this I can tell you always the returning value will be of positive, because the length will be positive or 0. So here we want to initialize some value which is not equal to 0 or the positive value. So I can initialize like minus 1 or minus 2 or minus 3 or infinity or minus infinity, anything, but all the values should be same. Like if you want to use null, then all the values should be null. If you want minus 1, just all the values should be minus 1. Okay, fine. So this is what the next step. The next step only we want to go here. After the base condition I want to add another one more step. If this name is dp, okay, if dp of index and previous index is not equal to minus 1, which means it is already computed, then return dp of index and previous index. Okay, and then before returning here also I want to just store it in the dp, then only I want to return it. So dp of index and the previous index is equal to max of take and not take. Okay, then only return it. So what is these two lines are indicating? So the bottom two lines, these two lines are indicating like we are just updating our matrix. So we are just updating our matrix. In these two lines we are just denoting like if it is already computed, then don't go to the body of the recursion, don't go for any other further recursion call, just that itself return it. So now hope you understand what these two lines means, right? So this is going to be your overall changes for the memoization technique. Now tell me what is the time complexity. So the time complexity will be O of n square and space complexity is of O of n square, and it is because of one is we have used a matrix, another one is because of the recursion stack that is inbuilt recursion stack. Okay, so now why it is of n square? Because see here there are of combinations we can occur, like for one value there will be n possibility, for n value there will be n square possibility. Apart from that we have all the possibilities and all its answers. So whenever a recursion like this again occurs, then we not go beyond it, we will be directly returning the value. That's the reason why we only having the time complexity as n square. Okay, so let me show you the code so that you can understand this clearly. So before going into the coding part, I want to give some alteration here. I forgot to give the alteration. So see here what the alteration we have done is, for the previous index, what is the change I have done? instead of starting from -1, I have started from 0. Okay, then whenever there's a previous, then we want to put +1 there. So here +1, and here also +1, and here also +1, and here also +1. Can you understand this? Can you understand this? Okay, so whenever previous is -1, in terms of the matrix, we'll be starting from 0. From the 0. That's the reason why I am just putting the +1 in terms of previous in this value. Okay, so whenever you are using that, you want to put like +1. Now let us get into the coding path. So see here. So this is going to be a coding path. So initially I'll be having a DP array of n square as a dimension, and everything is filled as -1. If you want fill everything as null or infinity, int max or minimum, that's your wish, but it should not be a return value from the any function call, and also it should be same for all the values in the matrix. Okay, now this is same thing as you already saw in the recursion, and the new line I have added is this line. So now hope you understand why I am putting the previous in this +1, because our previous is starting from -1 in terms of recursion, but the previous in this is starting from 0 in terms of matrix. So we want to add +1 so that the previous index will be going on to the correct particular index. Okay, fine. Now rest of them will be same. At last I want to do these two lines also. Okay, if you submit this, it will be submitted successfully. Okay, now let us get into the next optimization technique called tabulation. Okay, so before getting into the tabulation, tell me why we need the tabulation. So for the tabulation, just go and see what is the space complexity of the previous thing. It is n square. Why? Because of the matrix and the stack. Okay, if we don't use the recursion, then the stack will be cancelled out, right? So for that reason only we are just getting into the tabulation. Now hope you understand why we are getting into tabulation. So if you don't want to use the recursion, then we want to go for a looping. Okay, here also we want to follow some more steps so that we can achieve the looping. Okay, fine. So see here in the tabulation we want to follow some more steps. First of all, for the example 0, 3, 2, 3. Okay, here in memoization technique, how many rows and how many columns and what is the initial value we want? We want 4 cross 4. 1, 2, 3. 1, 2, 3. Okay, so we want 4 cross 4. Yes, 4 cross 4 rows, right? Okay, 4 cross 4 rows, and every values are initialized as -1. That we don't need in the tabulation. Okay, understand that we don't need tabulation, because in tabulation here we don't want to just update any value. We don't want to add or subtract any values. That you can understand when we are going for the coding part. As of now, just understand we don't want to initialize any values as of now. Okay, or else you can keep every value as 0, that's your wish, or every value as -1, that's your wish. We are going to obviously change it in a tabulation method. Okay, so the next step is always watch the base condition. So here what's the base condition? It is if the index is equal to the nums.length, then I want to return 0. So I already told you row is index, right? Okay, so for this, what is the length of this array? It is 4. Whether I have 4th index in my row? No. Then add one more row. Add one more row. Okay, and initialize everything as 0 because it is returning 0. Then initialize everything as 0. Okay, so this is going to be a first step. The next step is always eliminate this line. So we don't want this line anymore. Okay, now the next step is here. What are these lines represent? So these lines represent the body of the recursion. These lines represent the body of the recursion. So whenever we got the body of the recursion, just start with the looping. So put a for loop. Okay, first of all the index will be from where to where. So here where to where, the index will be starting from 0, will be going up to where, will be going up to nums.length -1. So similarly here also it will be starting from nums.length -1. So let me more formally write like n-1, okay, up to 0. Can you understand this? do a reverse fashion. There it is starting from 0 to n minus 1. So after this, I want to go for the next kind. What? So next varying parameter is previous in this. So this is the next varying parameter, right? So put another part. So previous in this will be from where to where? It is also from the n minus 2 up to 0. Sorry, up to minus 1, right? But this statement is wrong. What is the wrong in this? So observe this clearly. Many of them will be doing this mistake while converting the memoization into tabulation, because see here, previous in this will be always lesser than the current in this. So where should I start? I should be starting from in this minus 1, in this minus 1. Okay, start from in this minus 1, go up to minus 1. Okay, so this is going to be your two loops on the basis of varying parameter. Now go to the body. So this line, so put here not take is equal to, here it is a recursion call, right? This LIS is a recursion call. Whenever there is a recursion call, just don't go for the recursion call, instead take the dp of, here comes what, index plus 1, then previous index. That's it. Can I understand this? Okay, fine. Now I want you to understand another one also. So the previous will be from where to where? Will be from index minus 1 up to minus 1, right? So that's the reason why we altered the previous, like what? It is starting from 0 and ending at the index minus 1, right? So here I want to do what? Previous index plus 1. Can I understand why we are putting a previous index plus 1 at this particular point? Yes, because see here, my previous index is here of minus 1, but in my matrix, in my DP matrix, previous index will be starting from where? Starting from 0 only. That's the reason why I want to do plus 1, the representation. Okay, now what is the next step? Take. Okay, take is equal to 0. Now put the same condition here also. Okay, now inside that condition, take is equal to, what is the take? LIS 1 plus, so 1 plus LIS. Whenever there is a recursion call the dp of, what is here? It is index plus 1 and next one is index. Okay, now also listen this carefully. These two are the varying parameters, so I written here. Okay, now here comes what? Here comes it is index. So index is starting from 0 to 0. Index is starting from 0, but my previous index, so this column represent to the previous index. So my previous index is always present at where? Present at the starting at the minus 1, starting from the minus 1. Can you understand this? So see here our previous index is 0, 1, 2, 3, but actually our previous value is what? Minus 1, 0, 1, 2. So obviously here also I want to put plus 1, index plus 1. Can I understand this? If I put index plus 1 here, then it means here, what is the length? Length is 4. So what is the last index value? Last index value is 3. So 3 plus 1 is equal to 4. But whether we have 4 as the column number? No, we don't have 4 as the column number. So add another column. Can I understand this? Why I am adding another column? So how my matrix looks like now? My matrix is now n plus 1 cross n plus 1 matrix. Now hope you understand why I added this particular row and this particular column. Can I understand this? Okay, so this is what the modification we have done in the matrix. Okay, then what is the next step? Just go to this line, this particular line. So dp of index and then previous plus 1, which is equal to what? Which is equal to maximum among not take and take. Okay, then ignore this written. Okay, ignore this line also. Now at last, what should I return? So here what I am returning? Here I am returning 0 and minus 1. So here also I should be returning, just return 0 and minus 1, but is that dp of 0 and minus 1, but minus 1 is not a starting point, right? So what is the starting point? It is 0. It is 0 for the previous, right? So here also it should be 0. Here also it should be 0. So this line, many of them will be doing a mistake, and this particular line and this particular line, and then here adding this one more column. So here many of them will be doing a mistake, then here they will be starting from n minus 1, but we want to start from index minus 1. So these are the all parts where we will be commonly doing the mistakes. So by solving much more DP questions, you can understand why we are just increasing one and why we are starting for the previous as index minus 1, everything. Okay, always be careful when once you are just converting the memorization into a tabulation. Okay, there is a much probability of making these mistakes. Okay, now tell me what is the time complexity. It will be n square, and space complexity will be O of n square. But this space complexity is because of what? Because of the because of the auxiliary matrix, not because of the recursion stack. Because we eliminated the recursion stack and converted into a looping. Okay, now let us see the code. So see here, this is going to be a code. So entirely everything will be same as I told you. So see here, it will be n plus 1 and n plus 1 we have altered, and then here it will be starting from n minus 1 up to 0. Here it will be previous will be starting from index minus 1 up to minus 1. Can I understand this? Okay, now here take will be like index plus 1 and previous index plus 1. Can I understand why I am putting previous index plus 1? Because in terms of recursion, in recursion we are accepting minus 1 also, negative values also, but in case of array it will be always starting from 0. So we want to convert that minus 1 into 0, which means plus 1. So that's the reason I put that plus 1. Okay, after solving many DP questions, you can understand this clearly. Okay, I know in your first try you cannot understand much clearly, but watch my video for second time or third time and solve and use the dry run technique. I studied this DP using the dry run method. Okay, I always take some example and dry run this code. It will take me 2 hours to learn one DP question. Okay, that's no shame. You can learn 2 DP questions per day, so that you can complete the DP series up to the medium problems in 3 months. It took me 3 months to learn DP. Okay, it is a long journey for me, but for you it will be a short journey, because many of them will have a different mind capability. Okay, I have very small. Okay, fine. Now int take is equal to 0. Now here comes previous index. This condition is same as the previous, that recursion. Now the only change here also it will be dp of index plus 1 and not the index. It will be again the index plus 1, because here the index is pointing out the row, but we want the previous index, the column. That's the reason why I'm putting a plus 1 there. Okay, I clearly stated the drawing explanation, right? Now remaining things are similar to the drawing explanation. So this is going to be a tabulation method. Fine. Now let me take this tabulation method. Now next thing is space optimization. So all codes cannot be done doing a space optimization. Some few codes may be done the space optimization. Okay. So to check whether we can do a space optimization or not, we want to go with some particular conditions. Okay. So let me put up number 4, space optimization. Okay. So from this I can tell you we are going to remove the unwanted space. So see here, we want a n cross n matrix, n plus 1 cross n plus 1 matrix. But if I just observe this code clearly, then I can frame some array or matrix which is lesser than this space. Okay, so follow me. See here, inside this inner loop, whatever space we need dp of index plus 1, dp of index plus 1, and then dp of index. So from these three lines, I can tell you easily, we only want 2 rows, but n plus 1 columns. Can you understand this? We don't want all rows, we only want 2 rows. So let me take one as previous row and another one as a current row, for example. Okay, so previous row will be consisting of n plus 1 column. For example, if the given array is something like 0, 3, 2, 3, then I want what is the length? It will be 4. So 4 plus 1, which is equal to 5, as you already saw here. Okay, so 5, 1, 2, 3, 4. Similarly for the current also. Okay, can I understand this? Okay, now come up with me. Now just remember, whenever I am having dp of index plus 1, Indus plus 1, there I'll be taking the previous. Whenever there is a dp of indus, then I'll be taking the current. Here I mean in first iteration, just follow the white color. In first iteration I'll be taking these two rows. Okay, in next iteration I'll be taking these two rows. Okay, in next iteration I'll be taking these two rows. Can you understand this? So by using this method, I can reduce the matrix into an array. Okay, so follow me. First of all, what I'm going to do, I will just leave as it is, because there is no initialization here. Because see here I have mentioned everything is 0, but the default value in the Java is 0, right? That's the reason why I didn't initialize anything. If you are using Python or C++, just initialize every value is 0. Okay, that's going to be your initial stage. Okay, every value is 0 in the previous. So here every value will be 0. As it is a previous row. Now I am at the current row. I will be calculating the values using the previous row, like that. Okay. Now what is the next change I want to do? Let me take the yellow color. Now see here, these two lines will be same. Now in this not take region, what I will be doing is not take is equal to dp of instead of taking dp of indus plus 1. What should I take? I'll be taking my previous of previous indus plus 1, which means take the previous rows, my previous rows indus, my plus 1. Okay, similarly here the next thing, so this line will be coming here also, and this condition also coming, but in this line I want to change like take is equal to 1 plus, so here comes dp of my previous only, dp of indus plus only. So here comes previous of indus plus 1. Can you understand this? Instead of this I just change it into previous. Similarly in this line also I want to change like instead of dp of indus, I'll be changing like current is equal to current of previous indus plus 1 is equal to what is the maximum among not take and take. Can you understand this? Okay, then I want to just initialize my currently computed result as the next, which means as the previous, which means previous is equal to current. Can you understand this, what I am doing? So initially let me take red color. Okay, initially these two rows are my these 3 and 4th row. These two rows are going to be my consideration. Okay, in next iteration I'll be initializing my 3rd row as a previous, and current will be obviously going to be 2nd row, which means in next time I'll be taking these two rows. In next iteration I'll be taking 1st and 2nd row. In next iteration I'll be taking 0 and 1st row. Can you understand this? So this is what I have wrote here. Okay, at last here one more line. What should I return? I will be returning previous of 0 or current of 0. That's your wish. Okay, because both of them will be same at this particular point. Okay, that's the reason why we can return any one of them, but it should be the 0th index of them. Okay, so these are the steps you want to do to convert a tabulation into a space optimization technique. Now tell me what's the time complexity? So I can tell you time complexity will be n square, but the space complexity will be what? O of n only, because we have taken two arrays which of size n plus 1. So which will be constant, will be eliminated, and space will be O of n. So let us see the code so that it will be more clear. We comment this, and this is going to be a space optimization code. So see here, I have taken, instead of previous I take here as next. Okay, because it is of the next row, right? So you can also take as previous, that's your wish, because it's just a variable name. Okay, so here I took as a next, there in drawing explanation I took as a previous. Okay, now everything are same. Whenever there is a dp of indus plus 1, that you want to substitute as next. Whenever there is a dp of indus, then you want to substitute current. Can I understand this? So these three lines are my target value. So there are, I just changed them. Okay, now at last I wrote like previous equal to current. Here instead of previous I used the next. So next is equal to current dot clone. Okay, at last you can either put next of 0 or current of 0, because when I encounter this particular line, both things will be same only. So and also they are not a local variable to this for loop. So you can use either next or current, that's your wish. Okay, so this is going to be your final space optimized version. Okay, so if you understood this problem and all the approaches, just subscribe to my channel and like this video. And if you have any doubts, just comment below. I'll be commenting out the answers. And to know about these kinds of algorithms and problems, just go and watch my YouTube video. There I have posted plenty of videos which will be helpful for you. Thank you.